Okay, here are the answers to homework number 3, section 9.3. You can see for problem 1, I have given you the vertices over here as well, and I drew the original shape, the pre-image, and the image. Number 2, again, I've given you the vertices of the image, and I drew the pre-image. And number 3, I have given you the vertices of the image and shaded it in, and I drew the pre-image. Number 10, there are the coordinates of the image. And number 11, there are the coordinates of the pre-image. Number 12, I have given you the coordinates of the image, and number 13 is a tricky one. There's that answer. Number 14, I have shaded in the image, and number 15, I have also shaded in the image. Okay, let's go through it. Number 1, I have already drawn the pre-image. This is supposed to be a rotation of 90 degrees. What you want to remember is when you're rotating in math, you're rotating that way. And we are rotating around the origin, which is that point right there. So the way to rotate this, or the easiest way to do it in my opinion, is to rotate your paper 90 degrees. So the x-axis ends up at the bottom. And that triangle has now been rotated 90 degrees, except I went the wrong way. How about we rotate it the way I drew the arrow so it ends up there? Now that triangle has been rotated 90 degrees. And if I record the location of the points, the location would be A prime, which is where A is now, is at -2, 2. B prime, which is where the B is now after the rotation, is at +2, +3. And C prime is at -1 and -3, -1. So now if we take the graph back to its original orientation, we can go ahead and graph these 3 points. -2, 2 is right here, that's A prime. +2, +3 is right here, that's B prime. And -3, -1 is here, that's C prime. And when I reconnect them, you can see that the triangle has rotated around the center point 90 degrees. Let's go to number 2. This time I'm supposed to rotate 180 degrees around this. So I'm going to go a rotation this way, right? This is the positive direction, 180 degrees. So if I turn the paper once, that would be 90. And if I turn it one more time, that would be 180. And then we'll go ahead and we'll record where is A prime, where is B prime, and where is C prime. Well, A prime is at -2, -2. B prime is at -3, +2. And C prime is at +1, -3. Those are the coordinates after I rotate the triangle. So now let's go ahead and put the graph back the way it belongs, but we can graph these 3 ordered pairs where they would be if I rotated the triangle. -2, -2 would be here. -3, +2 would be here. And 1, -3 would be here. And there is my rotated triangle. I've rotated it 180 degrees. Next up, I'm supposed to rotate 270 degrees. So 270 degrees, in that direction would be 3 turns of the graph. So let's go ahead and do it. There's 1 turn, that's 90 degrees. There's 2 turns, that's 180. There's 3 turns, that is now 270 degrees. And I'm ready to record where A prime, B prime, and C prime end up now that they've been rotated. So the A ends up at +2, -2 after the rotation. The B ends up at -2, -3 after the rotation. And the C ends up at +3, +1 after the rotation. So let's go ahead and put our graph back the way it belongs. And let's graph these 3 points after their rotations. A prime is at 2, -2, ends up right there. B prime is at -2, -3, right there. And C prime is at 3, 1, right there. Let's go ahead and reconnect them and shade it in. And I am done with that rotation, 270 degrees. Note that 270 degrees that way is the same as 90 degrees that way. All right, number 10. I don't have to draw number 10. I'm just asking what are the coordinates. So I have already drawn the shape PQRS. I want a rotation of 270 degrees. I always go counterclockwise. And since I'm going 270 degrees, I want to go 3 turns counterclockwise. So that would be 1. That would be 2. And let me get that back in. That is now 3 turns counterclockwise. This quadrilateral has now been rotated 270 degrees, and I can just write down the coordinates of where the points ended up. P ended up at 1, 2, 3, 4, 5, 1. So I'll go ahead and record that as 5, 1 for P prime. Q, after the rotation, ended up at 1, 2, 3, 4, 1, 2, 3, 4, -3. So let's go ahead and record that as where Q prime would end up after a rotation of 270 degrees. R ends up at -4, -2 after it's been rotated. And S ends up at -2, +3 after it's been rotated. And I now have the coordinates of where the quadrilateral would end up after a rotation of 270 degrees. Let's go to number 11. So the thing about number 11 that makes it tricky is we were not trying to rotate the coordinates I gave you. The coordinates I gave you were already rotated 90 degrees. That's what this means. The vertices of this rotation have coordinates of K prime, L prime, N prime, and N prime. What are the coordinates of the vertices of this? I'm looking for the pre-image. So what I need to do is I need to rotate it backwards 90 degrees to see where it started. So I'm going to go this direction 90 degrees, right? I'm going to go backwards 90 degrees to see where it started before it rotated. So a backwards rotation of 90 degrees would look like that. And I can go ahead and write down what the vertices were. So K prime is right here. That is at positive 2, positive 3. And we'll go ahead and write that down for K, positive 2, positive 3. L, before it was rotated, would have been here. That is positive 3, negative 2. M, before it was rotated, would have been here. That is negative 2, negative 4. And N, before it was rotated, would have been here. 2, 3, 4. It's negative 4, positive 2. So I'll let you see then. Those are the coordinates you would have gotten before the rotation. And I got those by rotating it backwards or unrotating it. We go to number 12. So number 12, you can see I've already drawn the triangle. And in this case, I'm supposed to rotate this triangle 180 degrees. So 180 degrees would be a rotation counterclockwise, one or two turns, right? 180 degrees is turn it twice. So let's go ahead and do that. There's a 90-degree rotation of the triangle. And there is a 180-degree rotation. And so now I can write down where those coordinates end up after a 180-degree rotation. So A, right here, ends up at negative 3, negative 1. B ends up here after a 180-degree rotation of negative 2, positive 3. And C ends up right here at positive 2, positive 1. Let's rotate it back. So I don't think it didn't ask me to draw the image, it just wanted the coordinates of the image, and we now have them. Let's look at number 13. Number 13 is a tricky one. So here's the trick to number 13. I am rotating point A, which I have already put on the graph here. I am rotating point A, but I am not rotating it around the origin. I am rotating it around the point 2, 3. Now, if you didn't get that, it's okay, but try to see what's going on here. If you want to rotate around the point 2, 3 instead of the origin, in my opinion, the best way to do it is to act like this is the origin and draw yourself a little X and Y axis as if that's the origin. And we're going to rotate this point A around this the same way we normally do around the origin. We're going to rotate our paper. And we want to go 90 degrees. So 90 degrees would mean I go that way, all right? One turn. Let's go ahead and go this way, one turn. And according to our fake origin, the point A, when rotated, is at positive 2, positive 1. All right? Positive 2, positive 1. So let's go ahead now and put it back the way it was and graph the point A around the fake origin at positive 2, positive 1. That would be right here. This would be A prime. So I have rotated point A around my fake origin, but when I give the answer to where A prime is, I need to do it for the actual origin or the actual graph. So where is A prime? in relation to the actual graph, 1, 2, 3, 4, 1, 2, 3, 4, it's at 4, 4. And we're done with that one. And then this brings us to number 14 and 15, which unfortunately, oh, it's just a translation. Okay, I did not pre-draw it. I wish I had. So number 14, m is at 2, 4, and n is at 1, negative 1, and p is at 4, negative 2. And I am supposed to translate this negative 3, 2, which is left 3, up 2. So let's take each point, start with n here, and go left 3, up 2. And here's n prime. And then with p, we'll go left 3, up 2. And there's p prime. And then with m, we'll go left 3 and up 2. And there's m prime. And if we go ahead and reconnect those, and that is my new triangle, translated left 3 and up 2. And then last up, I have this reflection across the line x equals negative 2. So when I do a reflection, the first thing I like to do is draw a dotted line at the line of reflection. Let's go ahead and put our points on here. P is at 0, 3. That would be P. Q is at 2, negative 3. So there's Q. And R is at negative 2, negative 3. That'd be R. So when I reflect across this line, I'm going to count to the line and then go across it. P is 2 spots to the line and 2 spots across. Ends up there. R is already on the line, and so it is its own reflection. That is also R prime. And Q is 1, 2, 3, 4 spots to the line, 1, 2, 3, 4 spots past the line. There is Q prime. And I have now flipped the triangle over the line. Hope that helps.